chemical to fix it. So we have a materials problem. 23% of all greenhouse gas emissions arise from material production. 99% of plastics are made from petroleum-derived precursors. And we throw away 590 billion pounds of plastic waste into the environment each year. So it's bad when we make stuff, it's worse when we throw stuff away, and we're running out of the stuff that we need to make stuff anyway. I'd like to tell a story. It's actually my story. In 2012, I was 24 and halfway through a PhD program in biomedical engineering. At this point, I had 6 patents or so in plastics, and I got a phone call from one of my best friends, who is now my co-founder in MIT startup Poly6. My friend had worked very hard to identify an opportunity in the area of sustainable materials. He was working for a fast food company in their corporate office, a company that makes the best chicken sandwich that I've ever had in my life. And this company, believe it or not, had a materials problem, actually 2 of them. Their 2 biggest waste products were citrus peels and styrofoam. It threw away approximately 40,000 tons of citrus peels per year and about 575 million styrofoam cups. Now, I'm really a creative at heart, and I jumped at the chance to design material systems using citrus peels and styrofoam. To accomplish this, I needed to invent 2 things. First, I created a high-performance plastic material. It behaves like plexiglass that I'm holding here, and it's called citrine. Citrine is made from natural citrus oil. And if you've ever sat at the bar and had a bartender squeeze citrus peels out into a drink and then maybe light it on fire, that molecule is called limonene. And to create citrine, we take limonene and combine it with other molecules in the presence of light to form this plexiglass-like material. This material in itself has immense value. And what's interesting is we figured out how to make this material even stronger by adding recycled styrofoam to it to form a nanocomposite material comprised of 80% either recycled styrofoam and recycled citrus oil. Now, this nanocomposite invention was featured in the 2014 Collegiate Inventors Competition in the US and was also published on the cover of one of the leading peer-reviewed scientific journals in the world. Also, from 2014 to 2016, I was, as far as I know, MIT's only fast food-sponsored medical technology researcher. A fast food company, a chicken company, sponsored research around investigating citrine for use in medical applications. And believe it or not, we learned that citrine has amazing opportunities in both biomedical device applications and pharmacology. This material is biocompatible, it's biodegradable in a unique way in the body, and it offers an excellent opportunity for drug delivery platforms based on the way it degrades. However, multiple years of potential research would be necessary to take this material to pharmacology, and more research in general would be needed for medical device development. Oh, and by the way, I hate doing research. By 2016 in the summer, I could not spend another second in the lab, and my co-founder in Poly6 was ready to leave his job in beautiful California to start working full-time with the startup company. And so by October 2016, my co-founder and I went full-time with Poly6. Starting a company is nothing like research, but it requires an immense amount of research. We had been working for years on scientific studies, on building materials based on the best attempt we had at looking at peer-reviewed sources. And all of a sudden, we realized that we needed to scour the globe to talk to people that had expertise in building materials companies. So we did. For months, we interviewed hundreds of experts in materials, and we realized that to build a viable company in the short term in the materials space, a significant amount of analytics about market research was needed. We found ourselves, after all this scientific work, doing more market research, generating plots like these, investigating and evaluating multiple markets for applications of citrine across 7 or 8 different materials sectors, looking at where gross margins and overall market size would enable a viable small company to exist. And after approximately 3 months of work, we landed on 3D printing. Now, Fast forward to right now, and our company is focused on 3D printing, in particular on UV-based 3D printing. Now, we had to teach ourselves UV 3D printing, and then we realized that we needed to invent quite a few other things in addition to citrus plastic to be able to build a business in this market. So we did. We taught ourselves new principles of science that were unfamiliar to us in optical physics and physical behavior of materials, and we have built out one of the more differentiated and robust portfolios of UV-based 3D printing materials on the planet. Some of these materials are derived from citrus, others are enabled by citrus, and still others are derived from apples, cinnamon, sounds like Cheerios, from apples, cinnamon, flower extracts, and other precursors. We're a growing team from MIT and Georgia Tech, and we've raised sufficient funding to make a run at scaling quickly in 3D printing. So in closing, I love this picture. It's on the left at the image I'm looking at, but pictured is a smartphone that looks like a green field in the hands of a person, but with a cityscape background. And what this picture represents to me is an ideal of where society should strive to be. This is a society in the future enabled by and connected through sustainable inventions. Now, pictured on the right is Atlas, the mythological titan that holds the weight of the world on his shoulders. And I truly believe that the burden of preventing the catastrophic effects of climate change rests on all of us, but especially on inventors. It's interesting, we think of inventions as being heavy into science and engineering, but in its purest form, invention could be viewed as simply rearranging ideas or concepts to create something new. And when I invent a new material, I pull from principles in thermomechanical behavior of materials, in physical observations, and in chemical models. But I really see myself as using these principles to create in the same way that an artist might use red, blue, and yellow paint to create a beautiful picture. And finally, I would just like to encourage everyone in this room that the future of our society and the inventions that will help us save society from itself rest in the hands of everyone here. So thank you very much.